towards this to the cloud?
Okay.
Okay, good. Okay, well, let's see. I'm just going to go through here. As always, feel free to interrupt, ask questions. And then once I get through the my presentation part of this, which will probably take 20 minutes or something like that, we'll open this up for complete questions from you guys. Okay, so this first chart here, this is a life expectancy in Europe from 1860 through 2020. I'm just going to make my screen a little bit larger here. This is a very classic, what we call 3D scatter plot. So what we've got here along the x-axis, we've got a timeline that runs from like 1840 through 2020. On the z-axis, depth axis, we've got countries. And on the y-axis, we have our metric, which in this case happens to be a life expectancy. Very classic 3D scatter plot that you'll find in all sorts of different flows. Probably our single most popular visualization, actually. The next one, these are the 10,000 largest cities in the world. This is the classic display of what I call global metric. So each of these blue dots here represents a city in the world, and the metric coming off of it is designated by the height of the dot that's suspended above that point within the globe. And the point here is to be able to show on a global basis a metric. And this particular metric is the population of the cities. So this big red dot here, I think that corresponds to Tokyo, which on this data set is the largest city in the world. And other large cities such as Jakarta, Indonesia, are also prominently displayed here by the size and the offset of the dots. Okay. So for those of you who've been to prior sessions, you've seen that graphic before. If you've gone out onto our featured flows, this is an example of the charts that appear in the Texas power outage flow. This is an example of putting like 1, 2, 3, 4, 5 charts all on one chart. In flow, you can have any number of charts on a step, and those charts can be kind of similarly constructed, like this chart for temperature, demands, power demand, power supply, and price is. Or you could have maps on here. Any combination of flow data objects can go onto a step. And in this case, part of this data story, we were following 4 metrics. And we're also following for a very tight time frame that just ran for an hour or so, or a few hours, the frequency on which the power was being pumped into the Texas power grid. And this whole story, there's a complete narrative. If you go through this particular featured flow, there's a whole story about what happened in February of 2021. When Texas almost lost its entire power grid because they couldn't maintain the frequency of the power above 59.4 cycles per second hertz. Okay. That's an interesting story. It's a good one to go through if you want to take a look at a very sophisticated flow. This is also on our featured flows. This is electricity. Sources of electricity in the United States since 1950. And Michael has fairly recently put this flow up into our featured flows. I think it's been there maybe a month and a half, something like that. But this is an example of stacked bar charts where we're stacking the amount of electricity that comes from various sources: hydroelectric, wind, solar, nuclear, those types of power. Or a stacked bar chart for those sources of power is shown on the kind of upper part of the screen, and on the downward facing part of the screen is all the fossil fuel types of power that's being generated. So petroleum, natural gas, coal. So this is an interesting way of showing how power generation within the United States has varied since 1950 through 2020. And what the momentum changes are. So this is an interesting flow to go through. It's also available on our featured flow list. This concept of using stacked bar charts, very easy to do in Flow using the additional dimensions capability within the swarm definition, and it has many use cases. This is just one of them. There's another featured flow called Trump Tweets, and it's a presentation of Donald Trump's tweets when he was in office as president of the United States. More generally, this is a visualization that shows event occurrences. In this case, it was a tweet from Donald Trump, and the numeric values of those occurrences. In this case, it's likes for his tweets versus time of day, which is displayed here on the, or versus date, which is shown on the z-axis going into the screen, the depth axis, versus time of day. So an interesting thing about this particular flow is it uses time for two of the three dimensions that you can see. One is the date and one's the time of day. So that's called Trump Tweets. That's also a featured flow. There is another featured flow, which is called Temperature Anomalies. I think the name of it is. And this is a variation. This also uses time in two different ways, two different axes on this chart. This is what we call a 3D radar chart. We also refer to it as a tornado chart. And what this chart shows is global warming, basically, in the northern hemisphere, running from 1880, which is my vertical axis here, 1880 through 2020. Okay? And then every month of the year is displayed in a circular pattern for that particular given year. So, here we got January, February, March, etc. So this once again shows there's two of the three dimensions are devoted to time, in this case, year and month. And what this chart shows is the average temperature taken in the northern hemisphere for each and every month, for each and every year, going back to 1880. And kind of an average of all this occurred in like 1985, I think it was. That's this white line. That's just a reference point. And then you can see from this chart that these temperature measurements for every month and every year, they are outside the boundaries of what was kind of normal up through 1985. So on this chart, you can see the acceleration in the northern hemisphere of climate change that's going on. This is probably the clearest expression I've ever seen of the climate change dilemma that we're in right now. Okay. Another featured flow shows what I think are really good. It's a really good use of color and what we call area charts, which are these filled in areas underneath these curves. In this particular chart, this is estimated COVID infections starting in, I think it was January 2021 or 2021, running through that year and into 2022, or maybe I'm 1 year off. No, I think I've got my years right here. This was for three countries: South Africa, the United States, and one other country. So what this chart does very effectively, it displays three different curves of information all together in using different colors to show their relationships. And the three colors are deaths, which are the red line, hospitalizations, which are the orange line, and infections, which are the yellow line. And what this chart basically shows is that although we had some very large spikes in COVID occurring in the latter part of 2021, we did not see anywhere near the same level of hospitalizations or deaths that we saw in 2020 before vaccinations were available and before we kind of got a handle on COVID in some ways in these various countries. So this is called an area chart. And it's a popular visualization in Flow. Just putting some color underneath these curves really makes them more readable, more understandable, and more demonstrative of the point that's trying to be gotten across. So this is a featured flow also. One of our customers actually wrote a flow called "How Big is Big Tech?" And this is a chart that the author of that flow chose to show how big tech companies, the 5 big tech companies, Google, Amazon, etc., have gobbled up other companies in the IT space. And in this particular case, I think these 5 big tech companies have gobbled up more than 800 acquisitions. So each of these points represents an acquisition, and this particular point or this particular step, all these points are queryable, and you can click on them. You can see what their size are and who acquired them and things like that. So this is a very interesting flow. It's called "How Big is Big Tech?" Uses very bold colorization, and it's got a narrative, an audio narrative that the author put on it. So that's called "How Big is Big Tech?" There's also a flow out here that was some public available salary survey demographic information. So this was one way that we used to use a couple of things to show values in a way that are understandable, where the values are very divergent from each other. So on this, we've got a logarithmic scale of salary or compensation, I guess. Okay. So it starts at 0 and it goes out to people who've made $25 million a year or whatever, and shows the distribution of these salaries across different age groups. So here you can see, how each age group, what their comparative salary rankings were. This particular visualization uses a skyscraper display, which is a 3-dimensional display of dots. And this is used to avoid having a single stack of dots that goes way off the top of the chart. So this technique is available in what we call additional dimensions. Quite commonly used technique. It's fairly new, but it's gotten very good traction in our customer base. So this is a way of visualizing data that's diverging very wildly and has very large peaks and valleys. This next chart, this was put out about a year or so ago by the University of Kansas. This chart is a geographic hierarchy chart. So here, what we've got here, this is the number of children under the age of 6 all across the country. And in this chart, it's a little bit hard to see. I mean, it's a very wide chart. This shows the total number for the country. And then we've got regions of the country. We've got the South, the Midwest, the West, the Northeast. So each of the values of number of kids under 6 is shown there on a regional basis. And then that goes down into a state-by-state basis, and ultimately down to a population by county, I think it is. So anyway, this is a 3D hierarchical visualization. I forget the name of that featured flow, but that was put out about a little bit less than a year ago, and it's got some really nice graphics in it that have to do with this concept of hierarchy expressed geographically. Now, there are various ways of expressing values, and they each have different visual effects. A scatter plot typically takes a single point and displays it over time, and we've seen some of those charts in this presentation. There are other ways too, though, of expressing volumes. And this particular chart shows the number of people who are involved in different categories of a service industry. So we've got people who work in office and administrative support, sales and retail, food prep, transportation, production, things like that. So each of these dots is meant to represent 100,000 people or some such number. It's just a different way of expressing a volume, is by expressing in number of dots rather than a point on a scatter plot. This is also a very widely used technique within Flow. A lot of use cases for this. And whenever you have a concept where you're trying to get a point across a point that, hey, these are real people doing these things, using dots rather than a point on a scatter plot to represent visually a volume involving people is a very good technique. This next chart, newborn care over the course of a month. This chart also uses 2 of the 3 dimensions to express elements of time. In this case, this is kind of reminiscent of that tornado chart I showed before. We've got time going this way in terms of days. So each of these rings in this circuit, in this cylindrical display, represents a different day of the month. And then we have time going around here. So we start at midnight and go up to, we traverse the 24 hours of the day and then come back to midnight. Then we get on to the next day. And what the author here did, this is a newborn care flow to show, hey, where does all this time go for caring for a newborn? The different types of activity, giving the bottle, changing diapers, breastfeeding, all those have different colored scales, or different colors in representing that kind of activity. So the whole point here is to show how much time over the course of I think this is the first month of a newborn's life, goes into just caring for that newborn. And you can see from the colorization on this chart, it's almost a full-time job, okay? Or actually is a full-time job. Okay, this next flow, this was also put together by one of our customers. It was a demonstration flow and the topic that was of interest to this author was the origin of languages around the world. And what the author did in this case, he used a very attractive way of expressing a couple different concepts all in a single step, using two different charts. One chart was map-based, and it shows the locations of these various languages. And I think there are like 3,200 languages that he had in his database, spread all around the world. And then on the second chart, he wanted to show the relative population of people who are using these languages. So that's what's expressed in this chart of categorized columns that kind of surrounds the globe here. So this is a very interesting chart, especially in 3D, where you can spin the globe and you can kind of look at these various different types of language families that have to do with these languages. So I put this in here because it's an attractive use of two different, totally different types of charts, all displayed in a 3D space in such a way that the globe is in the foreground and the categorized columns are in the background. My single favorite visualization in all of the featured flows actually is a featured flow that's called the COVID Outbreaks in the USA by Day. And what this particular visualization does, and it loses a little bit of its luster in 2D on a screenshot than it does in 3D, but it shows a couple graphics. Here we have for the year 2020, we're going across this timeline and we're showing the total number of COVID infections in the US. So that's one chart. This other chart This is what I call the COVID shower that covered the U.S. And as you visualize this in 3D and can spin this space and look down through the shower, you can see exactly where the COVID outbreaks were at any particular time during 2020 within the United States. The animation on this is very interesting as the shower kind of emerges. If you want to take a look at a really interesting and innovative way of expressing geospatial data over time, take a look at this particular flow in our featured flows. Okay, the next one, force-directed graphs. We don't have too many applications that we find people are using this for, but for when you need a graphical display of a network of events, it's there, and it's a good one. In this particular case, this is also in our featured flows. I think this flow represents, or it shows up in a flow called flow about flow. Okay, and it's about 3/4 of the way through that particular flow. This step was put together. Actually, it's a series of steps, but this step was put together to show how COVID spreads relative to how a regular geometric progression spreads. So over here on the right-hand side, we have the regular geometric progression of a disease spread. So this person's infected here. He infects two additional people, and each of those, on the average, goes on to infect 2 additional people. There are a lot of processes in life that work this way. However, COVID spread is not one of them. COVID spread more takes place in clusters. So you've got this person who's infected, and he goes to a super spreader event, and he manages to infect 15 more people. And then each of those people go on to have their own history. So COVID spreads in more of a clustered way as opposed to a regular geometric progression. This next one has not been too widely used yet, although a couple of customers have made stunning use of this concept. It's a concept called point cloud. And basically what we've got here is I've got 50,000 dots. And these 50,000 dots are all being put into the image of a person. I think this person's sitting at a keyboard or something. But you know, it's possible using concepts of point clouds to actually have a 3D space that's defined, and then the dots, the data points, can be put in a random fashion into that 3D space. In this particular case, it's a man sitting at a computer screen, I think. We've seen all sorts of variations on this. The hardest part about this visualization is just getting the point cloud geometry, which is the 3D geometry into which these points can be taken. And then once you have that, and there are sites on the internet, by the way. If you do queries, you can go out and you can find information on point clouds. Maybe someday we'll have a library of them, but we don't yet. It becomes pretty simple, actually, to take a data set and kind of randomly position the dots within the geometry of this point cloud 3D representation. So that's called point clouds. Then the final one, this is also in our featured flows. I think this one's called COVID vaccines work or some such thing. On this particular chart, what we've got is a display. We're using a map of the United States, and we're using colorization to show occurrences of COVID. And this goes back into the year 2021, where vaccines were becoming quite commonly used in certain parts of the country and not so commonly used in other parts of the country. And it showed the relative the relative infection rates having to do with COVID as a function of vaccination status. So the red dots here are high infection rates and low vaccination rates. This aqua color here is low infection rates and high vaccination rates. And you can see how those occurred at this snapshot of the country at this point in time, which I think was taken in the summer of 2021. It was somewhere in that kind of time frame. So anyway, the purpose of this is just to show the diversity of the types of charts that can be done. And that's the whole reason we have our featured flows out there, is to give you guys a capability of examining flows that either we or our customers have written and that they've chosen to publish in our featured flows. So, those featured flows are there for your use and for your use in reverse engineering them, if you wish, and getting ideas from. And that's the point of this document too, is to kind of summarize 17 of these visualizations in one spot. Okay, I think I've been talking long enough. That's the end of this particular presentation. I'll open it up for questions either on this topic or any other topic having to do with flow. And Michael and I are here to answer questions for you. Okay, go ahead.
I was just say great run through, Bill. I think, where we're going with this is in some ways, we're planning to try to sort of rebuild all of the featured flows, and to do so by recording that process and teaching you how we rebuild them. Sort of an easier way to go about this. So anyways, I think this sets things up quite nicely. So yeah, good job going through all that.
Yeah, and let's see, I just have one other observation. If you have access to a flow, whether it's one of the featured flows or a flow that one of your colleagues has put together or something you've gotten from Mike or myself, I mean, all these featured flows are very reverse engineerable. When you look at the definition of each of these steps in the data objects timeline of flow, you can see what the data objects are and how they've been defined. And in doing that, you can go back, maybe with just a modest amount of study, let's say, you can go back through any of these featured flows and kind of figure out how these were all done. So flow is a product that is rich in the ability to do reverse engineering on a flow that somebody has put together. Let's see. I don't have anything else on this topic. As Michael said, we're going to spring off of this intro, and what we're going to do is we're going to put together some things that allow us to communicate to you the ways in which many of these featured flows were put together. So Nate or Angel, any questions having to do with this or anything else having to do with flow? Okay.
Thank you. No questions. Very interesting. Just I will watch once again the video. So it's okay for me. Thank you.
Okay, great. Well, let us know if you have any other questions or once you get into the flow editor, if you have any questions or whatever, you can find a lot of answers in our help center, but feel free to send us an email or communicate with us also. Okay, Michael, did you have anything
really
else?
helpful? Thank you. I'm sorry.
Oh,
I just want to say thank you so much. This was really interesting, and yeah, I don't have any other questions either.
Okay, good. Okay, good. Michael, is there anything else you wanted to cover today?
No, that should be it.
Okay. Hey, great. Thanks, everybody. Thanks for dropping in.
Thank you.
Thank you, Bill. Thank you.
Okay.
Thanks, everybody. Bye.
Bye-bye.
Bye.